Good morning. The past couple of weeks, we've been working on matrices. So, things that we know how to do so far, we know how to add, subtract, and do scalar multiplication. We know how to do matrix multiplication, and we know how to take word problems and organize it into a matrix and find different information based off of the matrices. This week, we're going to get into the determinant of a matrix, the inverse of a matrix, and some row operation. Still, hopefully, you'll find very similar and very easy for you, like the past topics that we did. But just make sure you're staying on top of your assignments and completing them day by day because you know the math is going to build off of your previous knowledge. All right, so let's jump into what we're doing today. Today, we're going to find the determinant of a matrix. Of course, as you watch these videos, it's very helpful for you to write down some notes. I actually have some stuff written down that I suggest for you to write down. The determinant of a matrix. It helps us find the inverse of a matrix, which we will talk about tomorrow. And it has some properties that are in linear algebra. And those of you that are interested in further up, higher level mathematics, it has some different properties in that. This is our notation here. So it's a straight line, and then this represents our matrix. So in this case, it's A, and then I have another straight line. You should have seen these two straight lines before when we did absolute value. It's the exact same thing, except for we'd have a capital letter on the inside that represents a matrix. So this symbol means we want to find the determinant of a matrix, and it could be matrix A, matrix B, matrix C, whatever the case may be. But this symbol means that we want to find the determinant of the matrix. You only can find determinants if the matrix is a square matrix. So matrix must be a square matrix. So write this in your notes, underline it, put a bubble around it, highlight it, whatever you need to do. You only can find the determinant of a square matrix. So we're only going to do a 2x2 and a 3x matrix, a 2x2 and a 3x3 matrix. However, you can find other square matrix, 6x6, 8x8. Just knock yourself out. But we're only going to do a 2x2 and a 3x3. So let's start with our formula. So for a 2x2 matrix, and if you have a 2x2 matrix that has different numbers in here, you find the determinant by doing A times D and then subtracting B times C. So that is our formula for finding the matrix, the determinant of a 2x2 matrix. So we do A times D. So we do the diagonal that way, and then we do B times C. So A times D is what I did in the green there. So that's the first direction. And then we subtract out B times C. So let's do the first example. We want to find the determinant for the following matrix. And we have the numbers -7, 2, 5, and 4. So the determinant is going to be, so this is A, B, C, D. A, B, C, D. So the formula tells us to do A times D. So -7 times 4. And subtract out B times C. So that is going to be 2 times 5. Again, formula says to do A times D and B times C. So your numbers are alphabetical, A, B, C, D. Just follow suit in your matrix. So we did -7 times 4, and then we're going to subtract that by 2 times 5. So of course, you can use your calculator, do your mental math, whatever you need to do to get to the correct answer. These numbers are not too bad. So this is going to give me -28. This is going to give me 10. So my final answer is going to be -38. So I did some mental math there, but you are more than welcome to type this into any kind of calculator. Just be careful with your parentheses and things like that and get the right answer. So -7 times 4 is -28. 2 times 5 is 10. Mental math or in your calculator. So the determinant of matrix B is -38. So our new word for today is the word determinant. So determinant. And you might even remember from a previous math class, you possibly should have heard the word determinant before when you were doing the quadratic formula. The part underneath the square root is also called the determinant. So the determinant, when I'm referring to matrices, A times D minus B times C. Let's definitely try another one. So this time I want to find the determinant for matrix A. Matrix A is 10, -4, 3, and 8. So I'm still going to follow my formula up here, A, D minus B, C. So I'm going to do 10 times 8. And we're going to subtract out -4 times 3. So either mental math or in your calculator, we will work this out. 10 times 8 is 80. -4 times 3 is -12. Add that all together, and our determinant is going to be 92. So your determinant can be a negative number, it could be a positive number, it could be a decimal, fraction, all that kind of good stuff, as long as you follow and do A times D and subtract out B times C. Let's try one more 2 by 2 matrix, and then we'll move on to a 3 by 3 matrix. So example, find the determinant for matrix B. So find the determinant for matrix B below. So here's my matrix here. Now, hopefully, maybe if I leave this here just for a second, maybe you'll start to be like, something's not right about this one. This one isn't like what Ms. Carver told me to do here, and you'd be correct. The determinant only works for a square matrix. This is not a square matrix. This has 3 rows and 2 columns. So this is not a square matrix. So we would say not possible. So you only can find the determinant if it's a square matrix. 2 by 2, 3 by 3, 4 by 4, etc., and so on. This is not a square matrix. It's a 3 by 2 matrix. So we would say not possible. So that is finding the determinant of a 2 by 2 matrix. Now let's find the determinant for a 3 by 3 matrix. There's still a formula for it. It's just a little longer, as you can see here, but I'm going to walk you through it and how to break it down and understand it a little better. So for a 3 by 3 matrix, you find the determinant by following this formula here. So for a 3 by 3 matrix, it has 9 elements. So A, B, C, D, E, F, G, H, I. And this is the formula that we're following. So somewhere in your notes, you want to write down the 2 by 2 matrix formula, and you also want to write down the 3 by 3 matrix formula. That way you can keep those handy as you work on homework assignments, quizzes, tests, and things like that. So define it for a 3 by 3. I take whatever number is here, multiply, then subtract it from whatever number is here, and then multiply using these numbers, and then whatever number is here and multiply it by this little section here. Now, I've drawn it out just to kind of help you understand the formula a little better, hopefully, so that you don't feel like, well, where did it come from and how can I remember it a little easier? Okay. So the formula is basically just taking this 3 by 3 and breaking it up into a 2 by 2. So the first part, and I'll do that in orange, okay, it's saying to take A and multiply it times E, I minus F, H. So I kind of broke that up here. This is still the 2 by 2 matrix that we just learned how to do. We just found that to do a 2 by 2 matrix, you do crisscross this way and crisscross this way, but you're using the first number in it. So I'm taking this A and I'm multiplying it by this 2 by 2 matrix here. Now I'm going to use, I'll use green. Now this part here, I'm still breaking it up into a smaller, something more manageable that we can do. Now I'm taking B, which is in the top row, and I'm multiplying it by this 2 by 2, so to speak, that's down here. So I'm multiplying it by this 2 by 2. Same thing that we just learned how to do. We just learned how to do crisscross, so D, I times F, G. And then the last one, and let me put that back up here. So I did this, and then I'm using these numbers that are in the green. And then lastly, I have C. So now I'm taking what's in the top row here, and I'm multiplying it by 2 smaller matrices, one smaller matrix, a 2 by 2 matrix. So we just learned that we crisscross when you're doing a 2 by 2 matrix. So this one is blue, and I'm using this section here. So I did that to show you that yes, it's a 3x3 matrix. It is, but what I'm doing is trying to still use what I just learned, which is a 2x2 matrix. Because for a 2x2 matrix, you take this diagonal and subtract out this diagonal after you multiply. So it's like we took the 3x3 matrix and made smaller 2x2 matrices. Regardless, this is still the formula that we're going to follow as we go through and do some examples in just a moment. Okay, so let's take a look at our first example here. All right. So for a 3x3 matrix, I'm using this formula here. So we're going to go ahead and set it up, and we're going to find the determinant for this first matrix here. So my formula says to take A and then follow suit. So this is A, B, C, D, E, F, G, H, I. So my determinant is going to be kind of long, so make sure you leave yourself some space. Okay. I'm doing 6, because that's A. E and I. And then I'm going to subtract out F and H. So let's make sure we understand the first part. Again, this is A, B, C, D, E, F, G, H, I. So I'm doing 6 times this diagonal and this diagonal. So think back to the little squares that I tried to pull out a minute ago. This top corner times this 2x2 down here. Then I keep following the formula. I'm going to do a minus. Now I'm using this one and these 4 numbers. So that is now going to look like 1 times 4 times 7 minus 5 times 2. And I do have a lot of grouping symbols here. I'm just trying to keep track of everything so you know that this is the first section, this is the second section. So I took 1, then I'm going to do D times I, so that is 4 times 7. And then I'm doing F times G, which is 5 times 2. So I'm just following the letters that are up here and placing the number into the correct spot. And then the last thing it says to do is plus C. So I'm going to maybe write right here. So C is this one. And I'm going to multiply by D, H, E, and G. So that is this square that's right here. So I'm doing D and H, and I'm doing E and G. So when I set that up, that'll be 1 times 4 times 8 minus -2 times 2. Close it, close it. Yes, it looks kind of long, but all I'm doing is taking the variables that they tell us there and plugging the corresponding numbers. If you need to, there's nothing wrong with you labeling that this is A, this is B, this is C, etc., and so on throughout the whole matrix, so that you can see that where the formula says A, I'm going to plug in 6. Where the formula says E, my E is -2. Where the formula says I, I'm going to plug in 7, etc., and so on. So don't hesitate to do an extra step if that's going to help you be successful. Now from here, absolutely, I would use my calculator. You could go down and break it up into one more additional step, like if you wanted to go ahead and just say that this was -14, and I will write that out for you so that you know what I mean when I say that. So if one more additional step before you use the calculator, if you wanted to break it down a little bit more and say that this was -14 and this was 40. So that's going to be us breaking that first part down. And I didn't need the brackets and parentheses there, just trying to show you where I got it from. And then if I wanted to go ahead and do 1, and I know this is going to be 28, and this is going to be 10, etc. And then this is going to be 132 minus -4. So what I did was just went ahead and broke down the two numbers that were in the parentheses. So you do not have to do this step. Just if you want to do one more additional step before you just plug it in the calculator. But you could just plug it in the calculator and your final answer for this determinant should be -306. If you wanted to keep going and do mental math and break it down some more and get 36 and get 18 and get -54, nothing's wrong with that. Okay, so options depending on what you need. If you want to plug it all in the calculator, I do strongly suggest you using Desmos so that you can get the brackets and parentheses and the layout down. But if you're going to use a regular calculator, you're just going to have to keep track of your numbers. By all means, let us definitely try one more example. And I'm trying to keep the formula in view so we can see it, but nothing wrong with rewriting it so that we will have it for this specific example. So this is a 3x3, and we're going to use our formula. All right, there we go. So it says to do A, and again, if you need to label your A, B, C, and D, I will quickly do that for us. A, B, C. Don't have to, but if it's going to help you keep track of what letter is what, nothing's wrong with that. So it says to plug in A, so that's 4. Okay. Now it says to do E times I, so that's going to be 1 times 4. Minus F times H. Okay, so that's the first part. Simply following, it says to grab E, that's 1. Grab I, that's 4. F is -2. H is 7. So I'm just plugging in what goes where. I put these in parentheses because you got to multiply first before you subtract these two numbers. All right, keep going. Now it says do B. B is -9. Now it says to do DI minus FG. So this is going to be -3 times 4. And then F times G. So D is -3, I is 4, F is -2, and G is 1. And the last thing, I will try to see if I can put it on this same line here. The last thing says to do C, which is 8. It says grab D and H. So this is D and H. So -3 times 7 minus E and G, which are both 1s. Okay. If you would like to do one more additional step, so there's not so much in the calculator, so this is going to be 4 minus -14. This is going to be minus, and of course you can clean that up. 2 negatives make a positive. -12 minus 2, and plus 8 times -21 minus 1. So just options. If you wanted to even go one more step and make this 4 times 18 plus 9 times -14 plus 8 times -22, you write out as many steps as you need, or you can just type it in the calculator. So this is going to give me -194. So quick recap. You only can find the determinant if it's a 2x2, a 3x3, a 4x4, a 5x5. It has to be a square matrix. Follow your formulas. Make sure you keep your steps nice and neat and straight so you're not losing a number, and you should be good to go.